Welcome to the Crazy Hat Chemist. So here we go doing another video on gases. Bam! So the ideal gas law. That's what we're talking about today. I know we used it in 2 previous videos, but I'm assuming that you've covered the ideal gas law just maybe slightly in the past, since this is high-level chemistry here. Here we go. So what is the ideal gas law? It is PV equals nRT. Pivnert. Pivnert. Okay, you can't forget that. P is for pressure. V is for volume. N is for moles. R is the gas constant. T is the temperature. Okay? And when can you use the gas law, the ideal gas law? You can only use it with gases. You can't use it with solids. You can't use it with liquids. You can't use it with things in solution. No way, no how. It can only be a gas. Okay, these are 2 of the many gas constants with different units, but these 2 gas constant values here with the associated units are probably the most frequently used. So the top one is there, 0.0821 liters atmospheres moles Kelvin. Those are the units, that's the number. Then the next one is 8.314 joules per mole Kelvin. Okay, so depending on the circumstance, you're going to use one or the other of those gas constants. There are other values that differ numerically, but then the units themselves would change as well. And those are perfectly viable. All right, so Pivnert, PV equals nRT. What I'm going to do is I'm going to rearrange this and do some substitution, and I'm going to solve for a density here. So you can always do this. I'm going to derive it for you, and then I'm going to tell you a way to remember it. Okay, so V is for volume, and the volume is the mass over the density. Okay, hopefully you got that part. That's super easy. Mass over density is volume. Okay, N is for number of moles, and that is the mass over the molar mass. That would equal moles. Okay, so what we're going to do is we're going to substitute in M, mass over density, for the volume, and then mass over molar mass for the number of moles. And that's what I've done right here. Then what I'm going to do is I'm going to rearrange this problem, and I'm going to cancel out things that are the same, and then I am going to solve for the density. Okay, so I'm rearranging things here a little bit here for you. Okay, and then what we're going to do, I've cleaned this up, made it look nice and pretty here. I got PM over D is equal to MRT over M, and you should see that there are some things that cancel out here. Okay, and then what we're going to do is we're going to rearrange this, and we got D is equal to PM over RT. So density is density of a gas. Density is equal to PM over RT. So do you know my first name? My first name is Phil. My last name is Montbriand. So PM, Phil Montbriand. Perfectly easy. My denominator term on this is RT. So that is I am at Rio, so Rio Americano High School, and I am a teacher, so RT. Or Phil Montbriand is a Rio teacher. Isn't that super cool? Or Phil Montbriand took Reader's Theater. Phil Montbriand took the regional transit bus. Anyways, you got the ideal gas law, PV equals nRT, or you got the density equation, and that is equal to PM over RT. Now, you don't need to rearrange and solve for that density equation. You might just be able to memorize it, or you could always use the ideal gas law. Now, remember, you can only use the ideal gas law when you got a gas. Doesn't work with solids, liquids, or solution. I am the Crazy Hat Chemist, and I got a crazy hat here. I am a parrot today. Have a great day. Give me a thumbs up. Subscribe to my channel. Bye now.